Hey guys, this is the next lesson, lesson 6, where we're going to look at the rest of the chapter 3, algorithms on graphs. As we covered 2 points already, Kruskal and Prim's algorithm last time, we're going to focus on the next 2 points in this chapter, and those are the points of applying the Prim's algorithm to a distance matrix. And in the second half of the lesson, we will also look at the new algorithm called Dykstra Algorithm, which one finds the shortest path between two vertices in a network. So let's start with the Prim's algorithm that is applied to a distance matrix. It is very useful to be aware of this option, because obviously when you have a large network with many vertices, you can use the distance matrix to write the information down and feed it to computer, and then computer obviously can follow the algorithm much quicker and can find the solution much quicker as well. So the algorithm works in 6 steps. After you complete and mark every single vertex, you know you are finished. You are starting with any vertex, whichever you like, unless it's specified obviously in the problem. And in the second step, you will delete the row in the matrix for the chosen vertex, and in the column for the chosen vertex, you choose the lowest undeleted number in that column as well. Do not forget to keep the track which column you are choosing as a first or second or third, because that will show you the basically the order of the arcs that you are adding to your minimum spanning tree. So again, just to repeat, Prim's algorithm, similarly as Kruskal algorithm, is looking for the minimum spanning tree. The difference is that the Prim's algorithm can be also applied on the distance matrix, what is very handy when it comes to the large networks. So let's look at how it works in reality. So let's look at example 1 that wants us to create or to find the minimum spanning tree for the network that could be written in the distance matrix like this. You might recall the distance matrix is recording the distances between two vertices, and unless the network is directed, then this matrix must be symmetric by the main diagonal, as you can see, because obviously from A to B is 27, either kilometers or meters or hours, depends on the unit, the same way as from B to A is also the same 27 units. So let's look at how the algorithm works. You can choose any vertex to start the tree, but in this question they tell us to start with vertex A. They do it basically for you to follow some structure, so it's much easier to mark than on the papers. But regardless, whichever vertex you're going to start with, it would be correct. The solution you will get will be correct, but follow the direction in the problem. So I'm starting with the A matrix, and I'm vertex, and I'm deleting the A row based on this step, and I'm numbering the column in the matrix for the chosen vertex. So this is number 1 now because it's the first one. And in the numbered columns that I already put the numbers above, I'm choosing the smallest number in that column or in those columns, depends how many I have. So in this case it's 12. So AC will be my first arc, A and C, and the number or the letter that is in this row will become my second column. Okay, so in this case, I'm going to look, and obviously you can delete the rest. I am looking now at number 1 and number 2 only on those columns, and I'm looking, or I want to find out the smallest entry from these that were not deleted yet. So 2747, 2328, and 7487. So the next one is 23. So my next arc would be AD. And I can delete this and put 3 about D, because that was where it happened, that the smallest number was. So now I'm looking in A, C, and D column and looking for the smallest number that is not deleted yet. So in this case, it's 15. And 15, I can delete the rest, is the B, so this will become my fourth column, and that would be DB. And then the last one, the ones that were not deleted yet, so it's 71, and 71 is in the E, so you can delete the rest, but you don't actually need to because that's the last one, so BE is also the last arc. So the arcs that the order of the arcs is AC is the first one, AD, DB, and BE. If you want, obviously you can sketch the minimum connector or minimum spanning tree, and then we can count also the weight, because this was AC was 12, AD was 23, DB was 15, and BE was 71, so the minimum weight is 121. It is enough. If you going to get a full mark, it's enough to show your process. If these numbers are going to match, that means the order will match, and obviously you need to write also the order in which the vertices or the arcs were added. Then you will get a full mark. So let's look at the second question. In this case, A, B, C, D, E, F, G, that means 7 vertices, represents 7 towns. And the table shows distances between these 7 towns in kilometers. Manager lives in town A and plans to start and finish obviously at home, and she wishes to visit each town and drive the minimum distance. So obviously she needs to find the minimum spanning tree. So starting from a vertex, that's where we're going to start because she lives there, we need to use the Prim's algorithm to find the minimum spanning tree. Do not forget to state the order of the arcs in which you selected them. So the first part says delete the row A, and I'm going to put a number 1 above the A column because that's the first one I am dealing with. And I'm looking for the smallest number in the A column, that's 130. And you can delete the rest of the row where it happens to be, and that's the E. So my first arc selected is AE, and E will become my second column. So that means now I am inspecting 2 columns, A and E, and I'm looking for the smallest number in these 2 columns. So you can find out easily by inspection that it's 82 and delete the rest of the row where you found it, that's the G. So the next arc selected would be EG, and my next column that I'm going to include is third one is the G. The smallest number in these 3 columns is 63, so that's in F row. So next one is GF, and F will become my number 4. And I'm looking at these 4 columns now. And the smallest number here, when you look carefully, is 105. What is a D row? So FD will be my next, and D will become number 5. Again, the smallest number in these should be maybe 110. So 110 is in the C. So the next is this EC, and then C will become number 6. And then the last one that I need to find that is not deleted yet is 90, and that's obviously in the B, so CB is the next arc, and that's last column that was considered. If you look at the weight, obviously you can count all the numbers that are in the circles, count them together, and that's 580. So the length or the weight of the minimum spanning tree is 580. So let's look at the guided practice. I'm not sure, I prepared several problems, I'm not sure if 2 or 3. Let's look at this one. If you want again, you can pause the video, do it on your own, and then compare, or if you are still unsure, then you can follow. The table shows the length in meters, the paths between 7 vertices, A, B, C, D, up to G in some network, and we need to use Prim's algorithm starting at A to solve the minimum connector problem. That means I'm looking for minimum spanning tree. Clearly state the order in which the edges were selected and then the weight and draw it. Okay, so we're going to start at A. That means the first thing I'm going to delete A, and I'm looking at the smallest number in the A column, that's 48, and I'm going to put number 1 above the A. So 48, it's in the B row, so means AB is my first selected arc, and then the B, I can mark it on the tree, and then the B will happen to be my second column that I'm going to consider as well. So now in these 2 columns, the smallest number is G. I mean, in the row G is the 55, so BG would be my next arc, and the G is my next column that I'm going to consider. So that means I'm going to put number 3 above that one. Now, in the columns that are already highlighted, the next smallest number is 63. What is the F? So BF will be the next arc, and then F will become my column number 4, and we can highlight that one. Considering the highlighted columns and the numbers inside of them, the smallest one now is D. That means, sorry, no, it's 85, my bad. See, it's very easy to overlook, so you have to be very careful. So 85, and then it is in the C row, so C will become, so GC is my next arc, and C is my next column. So this would be number 5. And now the smallest one should be 28, if I'm not mistaken, that's fine. So that's in the row D, so CD is the next arc, and D will happen to be the next column, number 6. Next number is 58. 58 is in the E, so DE would be the next arc that I can connect, and then E will happen to be the last column. The weight that we need to find, just add the numbers that are circled, and that should give you 337. Example 4, we will try to do a little differently. I'll provide a solution for you, and as you will go step by step, try to discover the step where the solution is wrong, okay? Or solve it on your own and compare it what you got, and I'll give you we will correct it together in the next slide then. All right, so I'll try to follow, and I'm not going to say where the mistake was, only on the next slide we will discover it again, and we can compare it with your solutions. So in A, because I need to start with the A vertex, so that's going to be my first column. A is my first column, and I'm going to delete the first row A, and I'm looking at the smallest number is in this column is 52, so I cancel the C row, and I'm going to put number 2 on the C column. So I have my arc selected is AC. So I'm looking at these 2 columns now, A and C. The smallest number is 67, so I'm deleting the D column, the D row, and the D column will become my next column that is highlighted, and the CD is the next arc. Then I have 3 rows, and I'm looking at the smallest number in these 3 rows is 41. That means it's the E, and E column will become my 4th, and DE is my next arc. And then highlight the E. The smallest number here should be 97, that is the F. So AF and then 97 and then 5 will become, F will become my fifth column, and then the last one is 84, what gives me the B, and then FB is my next and last arc, and then 6 is the sixth column is the B column. The weight is 341. So now you can compare it with what you got, and let's do it over and see where the mistake was, where the mistake happened. Again, I'm going to start at A vertex, so A will become my first column, and I'm deleting the A row. The smallest number in the A column is 52, so indeed C will become my second column. So AC will become my first, so I have AC, my first arc. Now I am looking at A and C columns, and this is the step where there was a mistake in the solution, because not 67 as they identified, but 58 is the smallest number. So AE is the next arc, and E will become my third column. So AE could be somewhere here. Now I'm looking at ECA, and the smallest one is 41. So 41, that's in the D. So ED is the next one. ED is my fourth column. Now look at these, 97. 97 is the shortest one, so AF. So 5 and AF. And then I have the smallest one is 84, what gives me 6 FB. So F and somewhere here would be B. So this would be the correct solution. Now when you look at AC is 52, then I have AE is 58, ED is 41, AF is 97, and FB is 84. And when you're going to add it up, then the weight would be 332. In the wrong solution, they said 341, but you can notice what they have done. They selected this instead of this, what is 9 units longer. So obviously 341 minus 9 is indeed 332. So this one is the correct solution. As said at the beginning of the lesson, in the second part of the lesson today, we will discuss the new algorithm that's called Dykstra algorithm. And this algorithm finds the shortest route between two vertices. Algorithm itself seems to be a little complex, so if you want, you can pause it, or you can look at the book on page 67, I think. Yeah, 67. That's where I got a screenshot from, and you can read it through if you wish, or what I would prefer, I would just show it to you directly how it works on the some example. So in example 5, they ask us to use the Dijkstra algorithm to find the shortest route between two vertices. In this case, it's between S and T. If the network is given like with the vertex A, B, C, D, whatever, and they tell you to find the shortest route between B to E, then you will mark the first vertex that you're starting with. The starting point is the S, and the terminal point, the final point, is the T. That's why they have S and T here already. What you need to do first, you need to transform this network into something like this, where every single vertex will be replaced by these boxes. In the first box, that's the vertex name. The second box will be reserved for the order of the labeling. That means the order as we will go through. And then this last box in the first row is the final label. And the big row in the bottom, this one is reserved for the working values, as you will see how they are changed in a moment. So the network was transformed to something like this. You don't have to worry about this. You can either sketch it very quickly, or if you use the iPad or you can print at home, you can find these templates on the same website where the solutions, the detailed solutions are posted. So I am looking for the shortest route between the S and T. So what you start with, what's the first thing, what you need to do obviously is to name the vertex where I'm going to start. So that's the first one. And then the value, the final label is 0. So this 0 is the starting point, and I'm going to add every single edge to the starting value. So 0 plus 5 is 5. 0 plus 6 is 6, and 0 plus 2 is 2. So now I'm going to look at all the vertices that are not final labeled yet, and I'm going to choose the one that has the minimum value. So in this case, the minimum value is 2. That means C will become my second vertex, and its final value is the last working value, so that's the same one here, 2. And I'm going to do the same for the vertices that come out of C. The edges that comes out of C. That means 2 plus 2 is 4. And 2 plus 12 is 14. In case you will get a higher value here, like imagine in here I would have something like 5 and 2 plus 5 would be 7. You don't have to worry about it because it's the higher value than 6. So you just skip it. You keep 6. You don't have to. But that's not the case in this vertex. So now I have 5, 4, and 14. So obviously the smallest value is 4. So 4 will become the final value of this vertex, which will have the label 3. So 4 plus 4 is 8. 4 plus 8 is 12, and 12 is smaller than 14, so I'm gonna write it. And that's about it. And now the ones that are not marked yet, 5, 8, and 12, the smallest one is 5. So 5 will become the final value for this vertex, and it's the fourth vertex. So 5 plus 4 is 9. You can see I should put 9 here, but I'm not going to because it's a higher value than 8 already. So you can just ignore it. You don't have to write anything there. And now I have 8. 8 plus 3 is 11. And the smallest one is 8. So 8 will become the final value for the D, and that's the fifth vertex in a row. And then I have 8 plus 3 is 11, 4 plus 8 is 12, 2 plus 12, 14. So that's the final one. So the final one is 18, and that's 6. So what does it mean, the final value at the terminal? It means the shortest route is 11 units long. And now I just need to, so this is what I wanted. This is 11 units, either kilometers or hours, depending on the unit. And now I need to find the route, which vertices I have to cross in order to reach the final vertex, T vertex, in the shortest route possible. So I need to backtrack. So I'm going to write it here, backtrack. And I'm starting from T. So 11 minus 12 is minus 1. So that's not 2. So I'm not going to follow this path. I'm going to change the color of the pen. I'll do red. So I'm not choosing this one. Then 11 minus 8 is not 4. So I'm not choosing this one. But 11 minus 3 is 8. That is exactly this one. So 11 minus 3 is 8. That means TD or DT. So I want this. And I'm going to continue. So I am at D. The final value was 8. And I'm doing 8 minus 4 is 4, so that's not 5, so I skip this one, but 8 minus 4 is 4, so I'm choosing this. So 8 minus 4 is 4, so BD is the next arc. Now I'm at a B, so I have 4, 4 minus 6 is not 0, and 4 minus 2 is obviously 2, so 4 minus 2 is 2, that means the next will be BC or CB. CB. And now final one is 2 minus 2 is 0. What is what I needed? So it's S and C. So the shortest route possible is S, C, B, D, and T. And it is 11 units long, either kilometers, meters, or hours, or whatever the unit was. Okay, so let's look at the second one. We have similar story here, except in this case we have a directed network. There's a digraph where not all directions are allowed, and we will deal with it a little later. The network represents the road system in some city, and obviously, as in cities, some of the roads are one way. That's why you can see the directed arcs. Now, in the A case, we need to show there are two quickest routes from A to I and explain how you find your routes. So you have to do the backtracking and you have to show it, how you have done it. And then in the second question, in the B case, it says the HI is closed and we need to find the quickest route from A to I, avoiding the HI. So we will do that in the second part. So when you redraw, or you would get this template, and you would have every single arc with the 3 little boxes for the working values, for the final label, and so on. So I'm going to the next slide, and I copy the questions. Let me just change the color of the pen. I'm going to use the blue one for the working values. Okay, so I need to go from A to I. That means A will become my first vertex, and it has value 0. So 0 plus 5 is 5, and 0 plus 2 is 2. And I don't have to worry about this part because it's not allowed. You can see the direction is here. Okay, so I don't have to worry about that. So now I only have C and B to choose from, and obviously 2 is the smallest value, so C will become my second vertex, and the final value is the 2, so that will become the final label for the C. So now, because I have the final label for C vertex 2, I have to go on to all the vertices that comes out of C. So in this case, we have 2 plus 3 is 5. 2 plus 2, this 2 is 4. And 2 plus 5 is 7. So now the smallest value is 4 here. So my vertex B is the third one with the final value 4. 4 plus 4 is 8, this one. But I don't have to write it there because I already have smaller numbers. So 8 do not count. You don't have to mention it there at all. And then I have to choose between 5 and 7. So obviously 5 is the smallest value. So this is the final value for this vertex, and that's the fourth vertex in a row. So 5 plus 1 is 6. 5 plus 9 is 14. And 5 plus 11 is 16. So out of 16, 14, and 6, the smallest value is 6. So that will be my next vertex, 5. And then final value is 6. And 6 plus 8 is 14, what is already there, that's fine. And 6 plus 14 here is 20. So now the smallest value is 14, which will become the final value for vertex F, and that's the 6th vertex in a row. So 14 plus 1 is 15. 14 plus 5 is 19, and 14 plus 7 is 21, but again 21 is bigger than 20, so don't worry about that. Now I have 15, 19, and 20, so 15 is the smallest one, so 15 becomes the G vertex final label, and that's 7th in a row. 15 plus 2 is 17. And then I have 17 and 20 to choose from, so obviously this will be my 8th vertex with the final value 17. And 17 plus 2 is 19, which is the final value for the ith vertex, what is 9th vertex. So the shortest route would be 19 units, either kilometers or hours, I don't remember what was the unit, if it was even given. Shortest route is 19 units. 19 units. And let's try to do the backtracking. Backtrack. So now when I start to backtrack, I have to obviously start with 19, and I'm looking here, 19, let me change the color. So 19 and 17, so 19 minus 17 is equals 2. So that means I'm choosing this one because 19 minus this 14 is not 7, so I can skip that. And 19 minus this 6 is 13, and that's not 14, so I can skip that one. So my first would be HI. The next one is 17 minus 5, or 17 minus 14 is not 5, but 17 minus 2 is 15. 17 minus 15 is 2. What is GH? So I am here now. And then at the G, I have 15 minus 5 is not 11, so I don't have to worry about that. But 15 minus 1 is 14, so 15 minus 14 is equals to 1, that is FG. So I'm here. Now I have 14 minus 6 is indeed 8, but also 14 minus 5 is 9. So in here I will have two options. So I can say 14 minus 5 is 9. What will give me DF? Or 14 minus 8 is 6. What will give me EF? Okay, so let's finish first DF, this path. So I am at D. So 5 minus 2 is 3. So that's what I want. 5 minus 2 is 3. What will give me CD? And then the final one, what I am, 2 minus 2 is, or 2 minus 0 is 2. So 2 minus 0 is 2. So what will give me AC? If you want to finish from here, so I have 6. In this case, I can go 6 minus, so I cannot go this because I will not get 0, but 6 minus 5 will also not give me 2, but 6 minus 1, so I can't go. 6 minus 1 will give me this 5 here. So 6 minus 1, or 6 minus 5 is equals to 1. What is DE? And then when I am at D, then it will be the same. So 5 minus 3 equals, or 5 minus 2 equals 3. What is CD? And then the last one is 2 minus 0 is 2. What is AC? So I have two options. I can go, the first one would be A, C, D, F, G, H, I, or the option number 2 would be A, C, D, E, F, and the rest is the same, G, H, I. Okay, the root still would be 19 units long. So we have two options. Now for the B case, I'm going to change the color for this one. For the B case, you can look at H and I is closed, so I can't use this. Okay, HI is closed. So that means I have to delete the final value, that's 19, because I would not get that one, because from 17 plus 2 I couldn't go. So the smallest value, so I would have 20 here. Okay. And now I would repeat the same steps, the backtracking with the green color. So I have 20 minus 7 is not 14, but 20 minus 14 is 6. You can either do 20 minus the length of the edge, you have to get the final value, or you can subtract the final values and you have to get the weight on the edge. It's up to you, that's fine. 20 minus 14 is 6, so I would have EI. Now I am at E, so I am here, and I can go from E, I can go to D, because 6 minus 1 is equals 5, so that will give me DE, and then from D I repeat, I can get to C, so 5 minus 3 equals 2, so that's CD, and then from 2 minus 2 is 0, what is AC? So the root that I would get, the shortest one if HI is closed, would be A to C to D to E and then to I. And that would be 20 units long. Okay, so I think it's the time you will try. I know it might be a little confusing at first, but take it step by step. And I prepared on purpose here the animated ones, so you can pause the video step by step and consult your own template or your own picture. Okay, so we have the network given here. We are asked to use the Dykstra algorithm to find the shortest from A to I. So A is here and the I is here. State your shortest path and its length, okay? And it's absolutely necessary to show your working in the boxes, because this is what they are actually checking when they are looking at your problem, at your solution, I mean. So let's look at the label. Okay, again, you can pause the video or you can pause it step by step as we will go through. So I'm going from A to I, so A is the first one and 0 value. 0 plus 23 is 23, 56 is 56, and then 39. The smallest value of these is 23, of these three is 23, so I am choosing this one as my second vertex, and then the final label is 23. 23 plus 27 is 50, 23 plus 28 is 51, that's smaller. And now I'm choosing out of these trees. So the smallest one is 39, so that will become my third vertex. And the 39 is the final value, final label of the C vertex. Now 39 plus 20 is 59, but that's higher than 51, so you don't have to worry about that. Then 39 plus 44 is 83, and 39, 83 is 122. So I'm choosing out of these four, the smallest one is E, so that will be my fourth vertex. Fourth vertex, final value 50. 50 plus 11 is 61. Again, it's higher than 51, so don't worry about that. Now, choosing out of these three, D is the smallest one, so that will become the fifth vertex. That's 51. And 51 plus 37, 51 plus 21, and choosing out of these three vertices, 72 is the smallest value, so F is my sixth vertex. Final value is 72. 72 plus 15 is 87. 72 plus 44 is 116. And 72 27 is 99. So choosing out of these three, smallest one is 87, that's number 7, and the final value is 87. 87 plus 21 is 108, and now out of these two, obviously 99 is smaller, that's 8 vertex, final value, and 99 plus 20, that's too much, 119 is more than 108, so the final label of the I vertex is the 9th vertex, and the shortest root is 108. Now I need to trace back from the end, and as the algorithm says, include those arcs that will match, the difference will match their weight of the edges or the arc. So I minus 20, 108 minus 21 is 87. So I am at G now. G is 87. I have choice between minus 15 and minus 37. And I have to get the matching value, so that's the 72. So that's F. Then F minus 72 minus 21 is 51. I am at D. 51 minus 28 is 23, so I'm at B. And 23 minus 23 is 0, I am at A. So shortest path is A, B, D, F, G, and I, and the length is 108 units. So the next problem is actually related to the previous question, so I'll just redraw, because the girl that was asked to go from A to I using the shortest route now wants to stop at the vertex E, where there is some theme park, some attraction. So she needs to find out the minimal length that goes from A to I, but is stopping at the E vertex. Okay, so I can just go on up to B, that's fine. But from B, I have to go to E and then go to D and continue to I. But what happens? If I go to E, that means from E, 50 plus 11 will be 61. So if you go via vertex E, you will reach the D 10 units later, either 10 minutes or 10 kilometers or whatever. So instead of 51, I will have the final value 61. And that will change all the final values in the following. So in the following vertices, that means 72 will become 82, 87, 97, and 108 will become 118. So the shortest route that you will have from A to I that goes and stop at the vertex E will have the length 118, and obviously it goes from A to B, then stopping at E, and D, F, G, I are the same as before. So this is all for today. We have covered 2 points, Prim's algorithm on matrices, and we have also covered Dijkstra algorithm. If you have finished all guided practice and you are okay, that's perfect. If you do have some question, then please come to tutorial and we will clarify your doubts, and we will also practice these 2 sets and these couple of the problems that are here. If you want to do it alone, feel free, and then just come and consult your problems if you have any. As before, the detailed solutions can be found out on this website. You can also find the templates there. So if you are using the iPads, you can just download a PDF and then write directly on the template, or you can print it in the school and then just fill it out on the paper. I'll see you next time. Bye-bye.